Well, hey everyone. Hope you're having a great Tuesday. My name is Heidi Reese, and I'm sitting here with Chuck Hoke, and we are having Training Tuesday today. Our discussion is on the space lift jump forming system. That's a mouthful, huh? And I'm real excited to learn about this. This is something I actually don't know much about, so this will be really great for me. I hope it is for you as well. A little bit of housekeeping for you. Everyone who has joined the call has been muted so that everyone can enjoy the presentation and can hear it and whatnot. Don't let that stop you from asking any questions or commenting. You can do so through the chat functionality in the Zoom application. And while Chuck's presenting, I look at that and we will get everything answered for you or, make your comment for you. And then definitely at the end, there's a mini question answer session that we can handle as well. I want you to go ahead and remember that we record all of these. They are posted out on our YouTube channel for Dayton Superior, as well as our DaytonSuperior.com website. So everything that you see within this presentation today is anything technical you can find on DaytonSuperior.com. That's specifications, technical information. So be sure to check that out. In addition, who is Dayton Superior? We are the leading provider of engineered solutions for the concrete construction industry. I hope you all knew that, but just wanted to let you know we're not just about the forming. We are also about accessories and chemicals. We handle engineering, and I hope you understand we do training. If you need more training than just Training Tuesdays, we'll talk about that at the end of the presentation, but we're here for you. We can do custom Zoom type calls in person, and you just can contact us and we'll see what we can do for you. All right, so today we've got Chuck here, as I said. He's our National Training Manager. For 49 years, Chuck has been in and around the construction industry, working 20 of those as an accessory, forming, or chemical dealer. He's done it all. Following that lineup, he came to Dayton Superior over 30 years ago, and he's had various roles that makes him even more intelligent than the dealer that he was. He's really just a breath of fresh air and knowledge on everything. I love working with him. It sounds like I'm kissing up to you, Chuck.
Sounds like it.
But he really does truly understand the ins and outs of the business. He's a great resource for us, especially for me and for the internals here at Dayton Superior and Symons. So with that, suck up, Chuck. Take it away.
Thank you, Heidi. And it's just to make a point from Heidi's opening here. Not everybody knows everything. It's always good to know other people in this industry who are masters at what they do.
So are you masters of the universe?
No, I am.
Okay.
All right, so let's talk today about the space lift system. The space lift typically is a system that's an accompanying system to all of our forming system. Typically, it's used to pour elevator cores, etc., usually in high-rise construction, somewhere in and around 4 to 6 stories is where it really becomes advantageous because of cost factors. Now, it is a crane-handled frame system. So you can basically gang form your elevator cores and actually use it to jump up. But once you make your initial pour, you can then jump your forms upward for the pour up above. The units are usually used in pairs, basically to support the exterior and interior. But when we're talking pairs, we get the space lift is basically, you'll see it as a forming system, a support system that works from the bottom of the form platform and works upward. It has to be used in pairs. The nice thing about space lift is it has a rollback carriage, which is why this is called a rollback system. What that enables you to do is pour your concrete, slide your form back so you can then move your form upward, but it also enables you to move the form out of the way for cleaning, oiling, and rebar work. So as we talked about the rollback system, it basically is just that. It rolls back. There is a trailing platform that you can assemble with this system that basically enables you to go down and do all your touch-up work, your finishing operations within the system. You can basically gain up to about 16 foot in overall height. The system will support that. It gives you 36 inches of rollback. Now, when you talk about 36 inches of rollback, that's 36 inches you can slide your form back from where it was initially put in place to pour your concrete. So that now gives you enough room to actually come back, set your steel for your next lift, clean the form, oil it, etc. And it gives you up to a 9 foot wide platform. The space lift here, typically you're seeing this system here is made up of a multitude of their various parts and pieces. It is used pretty much on elevator cores, airport control towers. The Dayton International Airport was the last one we did up here about 7 years ago with the space lift system. But we use this system on a lot of elevator core shafts because it is an excellent system, especially when you're looking at compared to some of the self-climbing systems and so forth. This system kind of fits into where it works from the fourth level, basically those projects that are 4 floors to 10 floors. It works awesome. When we're talking different sequencing on how the system is basically put in place, you're going to assemble the system, obviously. You get ready to pour your forms, pour your concrete, you pour it, you come back in, you strip and roll back the fly form, then move it upward with the use of a shoe. And the shoe basically is the attachment piece that you will put in place. The insert will get cast in the initial pour, or the pour you previously, and that enables you to actually jump your form up. And that's what's actually suspending all of this form system, including your trailing platforms, etc. So we've got a multitude of different options here with the swivel lift bracket. You got 5-inch or 8-inch Versaform whalers that'll fit to it. So you can then use a Versaform system to connect to it. You can also use steel ply, sim ply, and or Maxiform or Flexform. So it can be accompanied by any forming system within the Symons product line. Shear platform, basically positive support for any gang form. Basically, the form has a shear platform that it's sitting on, so you're definitely getting the support from the form system when you move it from pour to pour. You have a jump shoe. Explain what that was actually put in place here. The nice thing about our jump shoe is that it is actually independent of everything, and therefore, if you have a radius on the wall, you can actually make that so that your form, especially if you're using a radius form, comes into play here, and you can make that radius incorporated in your work platform. You do have an uplift lock, so you don't have to worry about the form coming dislodged for whatever reason. We also have a wind tieback system for basically any wind uplift that may occur within the platform. We also have versatility. We've got frame legs that are 4 foot, 8 foot, and 10 foot. Those are predominantly put in place for your legs coming back for your trailing platform. So you can either have your trailing platform real close at 4 foot, or you can have it at 8 foot, or you can make it at 10 foot below the initial concrete pour platform. We have swivel tube clamps on here for bracing. You'll find that that comes in real handy when you actually have to brace all of these component pieces, especially, and it gives you a quick disconnect and connect system, so that when you slide your rail back, you can basically disconnect the bracing on that, slide your platform back, your wall platform back, clean it, move your system up, put it back in place, and then reattach your brace. It also has the roll carriage, which we'll talk about. Has a definitive lock system on it, so that basically the system will go in place. They even thought of with a gauge on the bottom of the lock system that will help you going forward to know how far close you put it to the wall, in case you may have put it a little to form a little bit. The various systems that we have, you have steel ply, which is 2.5 inches thick, sim ply, which is 3 inches, 3.5 inches thick, Maxiform, which is like 6.5 to 7 inches thick. Those systems all vary in thickness, so basically it'll help you set your form so that you always have your form face right up to where the wall is located. Now, we've got, with our carriage assembly, as you can see, this carriage here is the starting point of the spaceless system. This is actually the component piece that will allow you to slide your form backward and then slide it forward to engage it to your wall face. There's an adjustment reference mark within the form, as you can see in the top square up on top there. There is a lot of little pieces here that coordinate that system and how to make it work. Here you can see the system here, the 9-foot work platform. Spacing, you got your slide back system in place. You got your plywood decking in place, supported by your HICO beams. The work platform is usually standard plywood. The rail system here that you can see will allow that formwork to slide forward and slide backward. You can adjust it. You have adjustment nuts on there for basically setting any cambers that may be associated with it. And you can also do that with your bracing that's included. Obviously, the built-in guardrail adapter so that you can actually attach your guardrail to make this obviously a safe work environment for everybody that's working up on top of it. The carriage and lock system that we talked about here, as you can see on the carriage and lock system, as the carriage slides forward, it's going to be connected to your form system. And what will happen is you can then set your system to the exact inch dimension as to where you need it, then slide the neck of that lever down, pin it, and you're ready to go. That now locks the system into place. It won't move anywhere because you've actually pinned it. That engages the lock mechanism on that system. The top of the shoe allows for a little bit of tolerance within the play. As we talked about, here's the rollback system. As you can see, that pin down at the bottom of the system will engage into that top slot of the shoe that you see in the center of the page. What this enables you to do is have a little bit of movement left and right. What you also are going to see is you have 2 pins down at the bottom here. Those are actually uplift pins. They actually help so that the form system cannot be uplifted until those pins are disengaged. Once they are engaged, the system is locked into place. The great thing about this system, as compared to some of the other systems, is each rail is independent of each other. So you basically can have a radius wall going up in place here with flex form. And you can make the connectivity. And you can see you got about out down to like an 11-foot radius is what you can do with that system. And it still attach your shoe without having to shim it to make the connection. So this enables you to put up to an 11-foot or down to an 11-foot radius. You can actually use your flex form with the spaceless system attached to the normal shoe without any shims. The carriage connections, here you've got the carriage assembly, obviously. You have hinge points here with connection studs and the space lift frame leg. That is what is dropping down to carry your trailing platform to actually where you'll have the guys so they can work below the actual concrete pour to finish the wall, rub it down, etc. And what you'll see is that they're having 8-foot or 10-foot leg connections to the carriage, usually using two frame fast pins, which are basically hardened steel pins, and then use a cotter key to lock it into place on the other side. As I said, these are hinged systems. So the reason they are hinged like this right here is because when you go to disassemble and assemble the system, you are going to want to lift the platform upward, then connect the piece laying down flat, because you don't want to have it hanging 20 feet overhead and having guys trying to work 10 foot up in the air trying to make the connection. Everything then for assembly can be done on the ground. With this system, we have a wind tieback system. Basically, this enables it's a kicker for it. It actually enables this system so it will not, it gives a little bit of sway in the wind, but sway will come, and then it'll push on the form, and then the form will actually flex back. By having a back bumper system here, which is on between the shoe and the frame, that system is bolted in, therefore spreads that load out over about 12 to 14 inches across the top of that. Use a tieback plate to make a connection. That once that tieback plate is then connected to the shoe, and then you run that through your frame, tighten it down, everything is therefore connected and pinned and tightened up, and can be easily adjusted for removal, etc. The space tube and clamp system. The tube clamp typically comes in place here, where you're going to be putting in your frame leg going down through the space. The kick, what we call a kick tube or kicker, is basically put in place as just that. It is a kicker for the bottom of the trailing platform, so that it doesn't have to, it runs straight perpendicular or straight down, depending on how much of a if your lifting platform or your casting platform is running at a 90-degree lift, then the trailing platform is going to run it at a 90-degree. The kicker platform actually holds it off of the formwork and actually allows it to position it so that it stays far enough back from the concrete that gives you enough room to work in between. The tube clamp typically comes in place here for how you're going to attach your pipe braces. That is fully adjustable with the holes located on the frame lift leg. You'll see that you have multiple holes here. About every 12 inches, there's a hole. you can make actually, I think the holes, excuse me, let me take that back. The holes are positioned every 6 inches, and therefore you can actually attach this lift leg basically up or down within 6 inches to get your final adjustment. Assembly. Once the system here goes into place, it's fairly simple to actually assemble the unit as we speak. Typically, you're going to have your frames, you're going to have them, lay them out on the floor. You're going to have your carriage put in place here. You're going to set that up so that it stands upright, and then attach your wall face to the front of it. And then obviously, you're going to attach your work platform to the top, what would be the front of the form, attach it, put your guardrail in, etc. Then on the bottom side where your lift frame is going to be is you will have lifting lugs. You can actually lift from that point there to assemble, carry it, and drape it into position. Now, once you pick that up from the system, you can then attach your trailing legs, either the 4-foot, 8-foot, or 10-foot trailing leg. You can also attach your guardrail, and when you attach your work platform on your trailing legs, you will have a fixed walkway bracket. Basically looks, it's just basically a solid tube steel. A couple of holes in the thing to actually attach to the lift legs or to the work platform legs. This actually gives you and has also some fins on the top there for connectivity to the plywood platform. It is a direct fixation. The walkway access bracket also bolts into the other end of the walkway bracket. And then you use standard dimensionalized lumber to make your work platform. Here's why I said it is a hinged component piece. So here you have your platform already assembled. You're starting to pick it up into place. When you start with it on the ground, obviously you don't need to have a trailing platform to finish anything because you're going to be working off of the ground. But when you start to lift this platform upright, now your trailing platform comes into place. Once you get to your second lift, your lift platform will slide in, your trailing platform slides in. You put the other pin in place where it's bent right here at the 90 degree with a 3/4 inch fast pin. And then you have your trailing platform already attached. Some people use guardrail, basically a tube steel platform on the front side so the guys don't have to worry about falling through.
That's good.
There is about, I'm going to say about 10 to 12 inches between the backside of that lift leg or that leg and the face of the concrete. So you're going to have, there is a little bit of room there. It would be a little bit difficult. Somebody like me wouldn't have to worry about it because there's no way I'm going to slide down in between the two.
Oh, Chuck. For those that haven't met you, I don't know if you know.
But typically what you're looking at is this system here with the jump shoe in place. That distance from the back or the front face of the lift leg, the space with tie back bracket and everything, you've got roughly 8 to 10 inches, maybe 12 inches of actual space in between there. So you want to make sure that the people, when they're doing the front, basically rubbing down of the trailing platform, that they are basically secure. Here's a couple of projects here, different elevator core shafts that were being assembled here. As you can see, the spaceless system with the trailing platforms Sometimes the trailing platform is more than, the 8 or 10 feet down. Sometimes it's 14 feet down. Primarily, that's allowing the concrete to have enough time to cure and gives them an area that they can actually finish from the level below to a little bit of what was above it. So therefore, any of the joint area where the platform actually, where you would have your lift joint, can then be addressed easily. And you can see here they are using steel ply as their forming system on this elevator core shaft. I will tell you, looking at the system right now, since we've introduced the Simply system here, the Simply has become the preferred elevator core shaft system, primarily because of the stripping capabilities, especially for the interior forms. The anchoring system is basically using an F56 1-inch diameter anchor. You've got a setting bolt that it's basically a coil bolt that you're putting in place on your formwork. It's just that setting bolt is just holding that insert in place, casting it into concrete. Once you actually strip that coil bolt, the setting bolt on there, you're going to start to raise your system up. You're going to attach a jump shoe into that place using a B14 coil bolt, 1-inch diameter. Basically that metal setback cone does have a hex head on it, and the hex head is put in place there so that it is easily removed. So you pop that out, pop the bolt in with the jump shoe attached to it, tighten it all down, and then you're ready to jump your form upward. Here you can see they have a little bit of a carriage adjustment with the whaler bracket. You've got there's a Versaform whaler that they actually used here for the system. Like I said, this system is very adaptable to any of the Symons forming systems. So we can see that we have, our 5-inch or 8-inch Versaform whaler systems, along with steel ply, Simply, etc. So, but you do have this one, the setting to bolt here is predominantly there to help set the camber of everything. Excuse me. Brace to whaler. It's a movable system that actually is adjustable by just taking 2 pins out, sliding the brace up and down, and then you can do the fine-tune adjusting on the brace itself. This makes life easy for the contractor when he's having to slide the system back, disconnect it, and then reconnect it. Just some more photographs of some different systems here. You can see the system here comes back in. You got support bracing coming down underneath and up on top. Platforms can be, up to 9 foot wide in spacing. A lot of times guys will keep it a little bit tighter based off of what size plywood and what they're using for support members underneath that plywood. Here's a couple of towers that were actually put up here in the Dayton area. As you can see, our local contractor, Dayton, was actually the contractor involved in these systems here. And you see that the crane here is actually in place of, on the second tower here, they're actually moving the form upward. Just starting to, they start at one side and then they'll start moving, walking their way right around the platform. As always, Dayton Superior, all of our products, we've got brochures and application guides that will basically accompany any of these systems, along with our ID charts, our product pages that are available, and our technical data sheets. And these are all available at DaytonSuperior.com.
And before you talk about this, Chuck, go ahead and put your questions in because we're almost at time if you've got any. So go ahead and do that in the chat functionality while Chuck tells you about other training resources we have.
Other training resources. We have actually made life a whole lot easier for you if you're looking for additional training information. Use your phone to snap a picture of that QR code right there and on your phone. This will actually enable you, set you right up to go through to DaytonSuperior.com. You can look for Training Tuesday if you're looking for any of the other classes, or you can actually email Heidi or myself at training@DaytonSuperior.com. And once again, this is the Spaceless System, and we'd like to say thank you for attending. And if you have any questions, please feel free to put them in right now.
Yeah, thanks, Chuck. So while you guys are doing that, if you do have questions, we record these, and I'll let you know when that recording is available. I know some of the Australian guys actually are excited about it. They couldn't make it because of the time zone difference, so they're going to play it back for their customers. And yeah, it should be exciting. Doesn't look like we have any questions. So with that, I want you all to have a superior day.
And have a good day, everyone.
Bye-bye now.